Good morning, students. Am I audible now?
Yes,
Are
ma'am.
you
Yes, ma'am.
okay? Okay, then let's start. Are you able to see the PPT?
Yes, ma'am.
Okay. So, in the last class, we were discussing some reference model of for the IoT. Okay. What do we mean by the reference model? Then to generalize our IoT architecture. Okay. Like whatever domain specific, it is not domain specific, it is generalized. For each and every domain, we will be able to follow this rules. Okay. Then to decide that general architecture, uh, they have followed some kind of reference models. Okay, then for some kind of reference models, we saw one model which was Purdue model. Okay, the Purdue model is generally majoritarily widely followed by all the manufacturers. Okay, so if a manufacturing process is happening, then there are 90% chances that they will be following the Purdue model. Okay, so in the Purdue model, we have taken the reference from the Purdue model and then we designed the IoT architecture. Okay, so we have taken some references from the Purdue model. Then it is not the only reference model through which we have taken the references. Okay, there is a different kind of model known as Industrial Internet Reference Architecture. Okay, a IIRA model. Now, this particular reference model was first published in 2015. Okay, and this standards-based architectural template and methodology enables industrial Internet of Things system architects to design their own system based on the common framework and concepts. Now the thing is, as you know, that this particular reference model was published in 2015. Okay, so this model is only 5 years old. But why do they need why there was a need to create this industrial IoT system? That was because that from the M2M architecture, M2M architecture evolved into an IoT. Okay, now as it evolved into an IoT, everybody was following different kinds of architecture. Okay, so that's why ETSI created the M2M architecture, and this IIRA was also created. Okay, so they were following some common framework and some common concepts so that it will be easier for laymen to understand. Okay, so this particular reference model addresses the need for a common architecture framework to develop interoperable double IoT systems for diverse applications across a broad spectrum of industrial verticals in the public and private sectors to achieve the true promise of double IoT. Now the thing is, as we have a diverse applications. Okay, IoT can be applied in so many applications like smart grid, smart city, healthcare, then autonomous vehicles. Okay, so all the applications are different. Now even though the applications are different, there should be some basic rules which everybody should follow. Okay, so those particular rules which are being followed, those that particular points were discussing the IIRA. The main point discussed was the interoperability. Now what do we mean by interoperability? In the first IoT, in the first or the second IoT class, we discussed that some of the definitions which is being needed. Okay, then the definition of the interoperability is that if my both the devices are following some different kind of protocols. Okay, let's say some devices are following LoRaWAN protocol and some devices are following Wi-Fi protocol. Okay, then these two protocols are different. So if these two protocols are different, and if we want to connect these two devices in our IoT system, then it's not possible. Okay, so this kind of problems were happening, so they decided that we should develop some kind of architecture in which we will be able to convert, or we will be able to translate one protocol to another protocol, just like we have designed a OSI layer architecture for our computer networks. Okay, now what does architecture framework contains? Okay, then you can say that The architecture framework contains information identifying the fundamental architecture constructs and specific concerns. Okay, फ्रेमवर्क में फंडामेंटल आर्किटेक्चर तो होगा ही होगा कि ओके कि बेसिकली करना क्या है, ओके कौन से रूल्स फॉलो करने, बट स्पेसिफिक कंसर्न्स भी फ्रेमवर्क में होंगे. ओके, स्पेसिफिक कंसर्न्स मींस स्पेसिफिक फंक्शंस एप्लीकेशन वाइज भी हो सकते हैं, और कैसे स्पेसिफिक कंसर्न्स हो सकते हैं. देन स्टेक होल्डर्स, व्यू पॉइंट्स, मॉडल काइंड्स, करस्पॉन्डेंस रूल्स एंड कंडीशंस ऑफ एप्लीकेबिलिटी. कंडीशंस ऑफ एप्लीकेबिलिटी मतलब एप्लीकेशन में हम लोग ये एप्लीकेशन को फुलफिल करने के लिए क्या क्या कर सकते हैं. ओके, सो दिस इज द पर्टिकुलर एप्लीकेशन वाइज. Now, according to stakeholders also the framework changes. Okay, according to viewpoint also the framework little bit changes. According to the viewpoint, there are different kinds of models which we need to design. Okay, now what do we mean by viewpoint and stakeholder? We'll see in some time. Okay, but the architecture framework will be, it will obviously contain the common architectural constructs from the IoT architecture, but some specific concerns will also be answered, like stakeholders, viewpoints, model kinds, and application specific. Okay, now why this particular framework will be useful, okay, or what kind of engineer uses this framework? Then you can say that system architects can use an architecture framework to discover, describe, and organize topics of interest or concerns about the system at hand. They can further use architecture representation to clarify, analyze, and resolve these concerns. Okay, that means that I know that you will be thinking engineer as a developer only. Okay, but in the company there is not only developer present in your team. Okay, obviously developer will develop this kind of framework, but there will be one system guy. Okay, the role of that particular system guy is, obviously you that system guy needs to know how can we develop the framework, but it is one stage above the developer. Okay, so he knows how to develop the system, but he won't be doing that kind of work. What he will be doing is he will be monitoring the framework. Okay, and he will be seeing what kind of concerns this particular framework needs to answer whenever some client is present in the meeting. Okay, then the client will tell his or own specifications, like I need this particular output, or I need this particular design. So according to that, system architect will say that, okay, how can we by analyzing this framework, I can say that I can provide you this, but I cannot provide you this. Okay, but particularly your application, this particular point is not needed, even though you are saying that this is needed, but by this point you will be able to get everything which you need. Okay, so these kind of things will be done by the system architects. So from the framework, either you should be able to develop the framework, or you should be able to understand the framework. Okay, so there are 2 points. It is useful to consider an architecture framework in this context to include an architecture frame and a collection of architecture representations. Okay, so that means that if you want to consider whatever architecture framework which is being designed in the industry, okay, nowadays you can directly get the architectural framework for any kind of application. Then the context is necessary. Okay, then you should be able to understand which architecture framework to decide. That will be decided according to your context, according to your specification, according to your application. Now, based on that architecture framework should at least contain an architecture frame and a collection of architecture representations. That means architecture frame means that the whole idea should be present, the figure should be present, and the different kind of representation should also be present. Now, different kind of representation means business level viewpoint should also be present, model level should also be present, so that it will be easier for us to use that particular architecture. Okay. Now, at the core of this description standard, they are viewpoints. Okay. Now, what do we mean by viewpoints? A viewpoint comprises conventions framing the description and analysis of a specific system concerns. A viewpoint frames one or more concerns. The term concern refers to any topic of interest pertaining to the system. That means, what do we mean by, first of all, what do we mean by concern? Concern means any topic which is related to our application. Now we know what do we mean by concern. Now what do we mean by viewpoint? A viewpoint comprises conventions framing the description and analysis of a specific system concerns. Okay, that means that application wise there will be so many different kind of concerns present. Okay, it can be a business level concern, it can be a, I think I've given the example that it can be a business viewpoint, it can be a usage viewpoint, it can be a functional viewpoint, it can be a implementation viewpoint. Okay, now what do you mean by that? For example, if you want to design or develop this particular framework, okay, then from the business point of view, that framework will be different. From the usage point of view, that means from the client's point of view, that will be different. From the functional viewpoint, that is, the developer is just thinking about how this framework will describe the functionality, then that viewpoint will be different. Implementation viewpoint, that means system architecture comes into the picture. That how now this particular design has been developed, but how are we going to implement it so that our client can use it? Okay, so according to the different viewpoints, now that viewpoints, that means that they will be they will contain the description of your application, they will contain the analysis of your application. Okay, but application is wide. They will have a specific system concerns, like from business point of view, this kind of points should be cleared. From implementation point of view, this kind of point should be cleared, otherwise I cannot use your framework. Okay, so based on the different viewpoints, there will be different architecture framework. Okay, so that means there will be one framework, but the frames will be different. Business viewpoint frame, implementation viewpoint frame, something like that. Okay, so some people say that architecture framework is specific concerns. Okay, it will also have the general idea, it will also have the specific idea. Okay, then in specific idea, these are the ideas that your framework will include. Okay, now I said that even the viewpoints are different and stakeholders are different. Then what do we mean by a stakeholder? Okay, then a stakeholder is an individual, team, organization or classes thereof having an interest in a concern and by extension an interest in the viewpoint and system. That means that whoever is participating in your concern, okay, in your application, that particular, either it can be a team or it can be an individual or it can be a whole organization, then those entities will be known as your stakeholders. Okay, then according to stakeholders also it will be different. Like if I say that my clients is a different stakeholder, then my developer team is a different stakeholder, then my the company which designs the architecture framework is a different stakeholder. Okay, so this kind of different stakeholders are present. Then according to stakeholders also, their architecture framework will be different. Okay, now to aid the tasks of describing, analyzing and resolving concerns, one or more modeling constructs can be defined as the model kinds for each viewpoint. The constructs of the viewpoints and their corresponding stakeholders, concerns and model kinds can be considered as the architecture frame, जो मैंने बोला था. Okay, that means कि stakeholders बहुत सारे हैं, viewpoint बहुत सारे हैं. Okay, then for a particular concern, business, let's say कि हम लोग business की तरफ देख रहे हैं और या तो हम लोग usage की तरफ देख रहे हैं. Okay, that is my viewpoint. Okay, then in my viewpoint there will be so many concerns कि okay, business के लिए efficiency बढ़नी ही चाहिए कैसे भी करके. Okay, फिर efficiency बढ़नी चाहिए मतलब मेरे profits या तो sales increase होने ही चाहिए. Okay, वो कैसे होते हैं वो मुझे नहीं पता है, उसके लिए मैंने इंजीनियर्स रखे हैं, बट मुझे ये पर्टिकुलर चीज चाहिए. ओके, सो अगर दैट मींस योर स्टेक होल्डर नीड्स दिस काइंड ऑफ पॉइंट्स टू बी अचीव्ड. Okay, so keeping those kind of points in mind, that is concerns in mind, viewpoints in mind, there will be one architecture frame for that. Okay, so that means different viewpoints will have different architecture frame, and this different architecture frame will have different stakeholders in that frame. ओके, सो ये फ्रेम के लिए स्टेक होल्डर क्या होगा, मेरी डेवलपर की टीम होगी, दूसरे आर्किटेक्चर फ्रेम में मेरी सिस्टम आर्किटेक्ट की टीम होगी, तीसरे में मेरे क्लाइंट्स होंगे, चौथे में मेरी ऑर्गेनाइजेशन होगी, समथिंग लाइक दैट. ओके गाइस, समझ में आ रहा है? यस और नो?
Yes, ma'am.
Nandini, Divya?
Yes, ma'am.
Okay. Then let's move to the next point. That is, now following this particular approach, they have designed a different kind of architecture frame. Okay, that means one architecture frame, if you can see this particular diagram, there will be one frame consists of viewpoint 1. Viewpoint 1 will have its own model, that is 1.1, and it will have its own concerns, that is concerns 1.1. Now that stakeholder will be different. Now again, in a different frame, the stakeholders will be different, the viewpoint will be different, the concerns will be different, something like that. Okay, so based on the frames, we will be designing the architecture representations. Okay, architecture representations means that in one frame itself, the whole viewpoint cannot be covered. Okay, so model kinds will be 1.1, 1.2, 1.3, 1.4, something like that. Okay, so whatever 1.1, 1.2, 1.3, so the combination of 1.1 plus 1.2 plus 1.3 will be one view. Okay, now the second view will, that means the second viewpoint, the different viewpoint, the different models and different concerns. Okay, so it is not necessary that for one viewpoint there will be only one concern and one model. Okay, no, that's not like that. For a particular viewpoint, we have so many concerns, and we will have multiple models for that particular, for our multiple concerns. Okay, so architecture frames means it will have only individual thing. Architecture representation means all my model kinds and all my concerns according to my viewpoint will be considered in my architecture representation. गाइस, आर्किटेक्चर फ्रेम और आर्किटेक्चर रिप्रेजेंटेशन में क्या डिफरेंस है वो समझ में आ रहा है? यस और नो?
Yes, ma'am.
Okay, so the thing is, let's say okay, so based on that, now one architecture representation में क्या होगा? Okay, then you can say that architecture framework means in a frame there will be a concerns wali frame, viewpoints wali frame, model kinds wali frame. Okay, then based on my stakeholders concerns viewpoint, there will be so many different kinds of representation, like representation 1 for viewpoint 1, representation 2 for viewpoint 2. Okay, then based on that we will be having multiple models. Now this is your industrial internet architecture framework. Now the representations are done, that means you have views and models. Now those particular views and models, that means you have multiple views and multiple models. This will go to your system architecture. Okay, because system architecture means the whole shenanigan. Okay, system architecture means पूरे system में आप जो भी use करना चाहते हो, all of them should be present in your system architecture. Okay, so after they have designed each representation and each model, this will go into your system architecture. Okay, and system architecture will provide some kind of feedback or the improvement that you can let clients need this. So the developer team should make some few changes in architecture viewpoint number 1 or architecture viewpoint number 2, something like that. Okay, so now again they will improve it, and then it will go to the system architecture, and then after that we will apply it to our IoT system. Okay, so this is some kind of model which industrial IoT has been following. So the IoT TWF, our IoT architecture has also taken into this particular reference model into its reference. Okay, so they know that, okay, according to the stakeholders, according to the concerns, according to the viewpoints, our framework changes. So for any particular IoT system, the framework should be different according to the different viewpoints, or according to the different concerns, or according to the different stakeholders. Okay, so IoT ने इसमें से क्या लिया है? IoT ने इसमें से ये पॉइंट लिया है. that okay हम लोग को फ्रेम और रिप्रेजेंटेशन मल्टीपल्स बनाने पड़ेंगे बिकॉज स्टेक होल्डर कंसर्न्स एंड व्यू पॉइंट्स मल्टीपल हैं इसकी वजह से ओके Now there will be something which this particular reference model doesn't include. Okay, then what are the things which it doesn't include? That means it does not explicitly identify the model kind as a key construct of its framework. Instead, it uses the concept loosely during the analysis of concerns in developing its representation. It also does not explicitly discuss certain architecture constructs, corresponding rules, correspondence, and architecture rationale. It leaves them to the development of concrete architectures as needed. Okay, that means this particular reference model is just saying that you can develop your framework by following these rules. Okay, but these rules are not specific. Okay, that means that for a particular model which kind of frame which you need to design, that this model doesn't provide. This model only provides that according to the different viewpoint they will have multiple models and multiple concerns. Now they are not talking about the framework, the construct of the particular framework. Okay, it is just everything is loosely defined and analyzed. So it depends on your system architect and your developer to gain this kind of knowledge from somewhere else if they are following this IIRA model for their IoT system. Okay, that means there are some rules and regulations which you need to be followed, like correspondence rules, correspondence and architecture rationale. Okay, now this particular thing has not been included in this particular reference model. Okay, but these things are needed. Okay, so that's why the IoT architecture was done, and they have included every kind of reference model which was there, and they have provided the simplified IoT architecture. Okay, now how many viewpoints are there? If you are not able to understand anything, then you can say that there are 4 major viewpoints: business, usage, functional, and implementation. Okay, now depending on that, there will be different frames, there will be different architecture representations, and so that means my architecture framework will be specific to my concerns, viewpoints, and the model kinds. Okay, then for a business viewpoint, the stakeholders will be different. For usage viewpoint, the stakeholders will be different. Okay, so this is the industrial architecture which was designed for the IoT. And this particular reference model is constantly being updated. Okay, it was published in 2015, but in 2019 it again got updated. Then in 2021 or 2022 they will update it again. Just like in your 5G, they are giving you the revised documents. Okay, like number 14, number 15, 16, 17. Just like that, even this kind of topics will have updated documents every now and then. Okay, I'm not saying that every year or every single month they will do it, but yes, in a span of 1 or 2 years, they will definitely update this reference model. Okay, according to the industrial standard. Guys, ये बात समझ में आ रही है? Yes or no?
Then now, yes, ma'am.
Okay, so this was one kind of reference model. Okay, the first reference model was Purdue reference model. This is known as a IIRA, second kind of reference model, and there is a third kind of reference model which is IoT-A. Okay, I know that this is so much to remember, but you don't need to remember each and everything about each and every reference model. Okay, you just need to understand that to create a simplified IoT architecture, first of all, there was no architecture, so there were so many problems. Now, according to the multiple companies were designing their own kind of architecture, so their own kind of reference model. So there was a need to have a unified architecture, okay, for the IoT that majority of the companies will follow. Okay, so but to get this unified architecture, you need to take the reference from the multiple reference models. Okay, because each and every reference model will be discussing about some kind of issues they are facing. Okay, and they would have provided the framework for that particular issue. Okay, So that means that you have to consider so many different kinds of reference models to create one unified IoT architecture, which will be followed by majority of the companies. Okay, so in that we will discuss top 3 reference models. Okay, the first reference models is particularly we have taken from the manufacturing part. The second reference models is discussing about the interoperability and the IoT in your industry applications. Okay, now the third reference model is talking about the IoT-A. Okay, IoT-A reference models means it is the IoT-A, and A stands for the architecture. So this IoT-A reference model has given you that it should have a unifying concept. It should have a unified architecture. Like we cannot like every system should be interoperable. Okay, so they have first of all raised this kind of issues, and then they have tried to provide the solution based on that. Okay, so that's why you can say that. This is also one kind of reference model through which our IoT-WF architecture was designed. Okay. Then whenever this IoT-A reference model was introduced, they have given the current they had given the current status of the IoT domain. Okay, that they said that there are fragmented architectures, no coherent unifying concepts. Solutions exist only for specific applications. No coherent approaches to implement the IoT have been proposed. ओके इम्प्लीमेंटेशन के लिए क्या करना पड़ेगा वो किसी ने डिस्कस नहीं किया. पर्टिकुलर स्पेसिफिक एप्लीकेशंस के लिए सारे मल्टीपल फ्रेगमेंटेड आर्किटेक्चर्स डिजाइन हुए हैं, पर यूनिफाइड आर्किटेक्चर डिजाइन नहीं हुआ है. मेनी आइलैंड सॉल्यूशन एग्जिस्ट. दैट मींस अगर आरएफआईडी में प्रॉब्लम हो रहा है तो आरएफआईडी रिलेटेड आईओटी सिस्टम कैसे डिजाइन करनी है वो डिस्कस किया है. फिर सेंसर नेट्स को डिस्कस किया है, वायरलेस सेंसर नोड्स को डिस्कस किया है. ओके, सो दैट मींस द solution exists for a particular point, but it doesn't exist for your particular system. Okay, little cross-sectional reuse of technology and exchange of knowledge. That means that it is not interoperable. So we can say that it is not the internet of things, but it is intranets of things. We need to go from intranet of things to the internet of things. Okay, so this is the reference model which raises the issue about each and everything, not only about interoperability or not only about specific solution, or not only about it doesn't have a unified architecture. Okay, it is raising every possible point. Now, so based on that particular status, they introduced one tree known as IoT-A tree. Okay, that means this particular IoT-A tree they are treating as a one kind of a reference, generic reference model. Okay, why generic reference models? Because they have taken several different kinds of businesses into the picture. Okay, so that means that, for example, if I want to do the online shopping, then what should be what are the issues that my IoT system is following in the implementation? Okay, so then based on my healthcare applications, what kind of solutions do I need to implement in my IoT system? Then based on my transportation, based on my manufacturing, based on my home automation. So they have taken everything into the picture, and then they have developed a generic model tree. Okay, so, or you can say that to generate different reference architecture depend on a specific domain, specific requirements. Okay, so this thing is for each and particular domain wise, they said that we have a domain specific architecture. Okay, so these things we can use as a blueprint for concrete architecture design. So whatever your domain is, okay, you should have taken a reference from the IoT-A reference tree. Now, based on that, they have given one generic tree, and they have also given the architecture. Okay, this domain model, communication model, information model. So this will be majority of the companies takes this particular reference model as the blueprint to design their own architecture or to design their own framework. Okay. So now, what were the objectives for this IoT-A architecture? Okay, that means establishing Internet of Things modeling foundation. That means whatever there was present, it was intranet of things. In a true sense, it was not IoT. So the objective of this particular reference models was that we should establish the Internet of Things, not the intranet of things. That means what do we need to do? So that means we have to provide the guidelines for the technical designs of its protocols, interfaces, and algorithms. Like we should give the idea about what kind of protocols you need. There are different kinds of protocols, right? Which kind of protocols which you can use, which kind of interfaces which you can use, which kind of algorithms which you need to use for your domain specific IoT domain specific application. Okay. Then building the enabling architectural framework for the IoT. That means now you know the idea about the protocols, interfaces, algorithms. Based on that, each and every domain specific should have each and every architectural framework. Okay. Now, federating heterogeneous IoT technologies into the homogeneous IoT fabric. That means that even there are different kind of protocols like LoRaWAN is present, BACnet is present, Wi-Fi is present, Bluetooth is present, Zigbee is present, Z-Wave is present. Okay. Now, these all are heterogeneous technologies. We need to design our network layer in such a way that they will become homogeneous. That means they are easily convertible. That means we can easily connect this kind of devices. So in the truest sense, we can say that these are the Internet of Things. Okay. So these were the main objectives. Then how are we going to implement it? Or what are the things which we need to implement if we want to attain this particular objective? Okay. That means we have to set up a reference model for the interoperability of the Internet of Things system. Okay, outlining principles and guidelines for the technical design and of its protocols, interfaces, and algorithms. Establishing corresponding mechanism for its efficient integration into the service layer of the FI. Providing a protocol suite based on open protocol centered around a narrow waist. Building novel device platform components, defining a novel resolution infrastructure, allowing scalable lookup and discovery of Internet of Things resources, entities of the real world and their association, implementing a real life use cases demonstrating the benefits of the developed architecture. Okay. That means these are the points which any IoT architecture should be able to give you. Okay. If they are not giving you this kind of answers, that means you shouldn't follow those particular architecture. Okay. That is not good for your IoT system. Now, what are those points? Okay. Then the first point is that we should have some kind of reference model through which we can design our architecture. Then that particular reference model should give us idea about the protocols, interfaces, and algorithms. Like for this particular application in the market, this kind of protocols are available, this kind of algorithms are available. And if you follow this algorithm, then you will get this kind of output. Okay. So it should have some kind of information about that also. Then it should have some kind of corresponding mechanism. The integration mechanism should be present. Okay. Now in my service layer, that means whenever I am the data storage layer. Okay. So for the data storage layer, it can store the data in any kind of formats. Okay. But now whenever we are giving our this particular data into our upper layers, then it should be into a readable format. Okay. So there should be some kind of mechanism which is being able to integrate all these different kind of formats of the data. Okay. Then once again, that we should, rather than using a different, we should always use the open protocols. Now, why do I need to use the open protocols? That is because that if I use the open protocols, that means I will, my interoperability will increase. If my interoperability will increase, that means my waist will be a narrow. Now, what do I mean by my waist will be a narrow? That means that the service layer doesn't need to perform so many things. Okay. If I say that if I followed the open protocol, that means the work of the service layer becomes easy. Okay. That means there will be no wastage of a particular frame or a particular data. Okay. Then according to the different kind of specification or different kind of application, we will have a different kind of infrastructures. Okay. Then this particular application, we are just saying that these kind of applications are present. Okay. But whenever you are giving the reference model, that means you should also give the use cases. That means, what do we mean by use cases? That means if I want to do the home automation part, okay, then you should give a use case of the home automation in which you have collected a bunch of several sensors. You have used either Bluetooth, Zigbee, or Wi-Fi, or you have used the combination of the Zigbee, Bluetooth, and Wi-Fi. And based on that, you have created one use case or the case study. Okay, so it will also have several case studies, real life case studies. Okay, that means that okay, home automation is real life, I want to use it in real life. Or you can say that autonomous vehicle, or you can say that some project related to the healthcare. Okay, that means that it is integrating several different kind of bunch of sensors like oxygen oximeter, then that means SpO2 sensor, then temperature sensor, then pressure sensor. Okay, heartbeat sensor, that is pulse sensor. Okay, they are integrating all this kind of sensors, and they are using open protocols, but they are giving you the case study based on that. Okay, so if your application is related to the healthcare, then you can just follow that particular case study, and it will be easier for you to design your architecture. Okay, so that means that these are the points that they have issued, that how are we going to implement a IoT architecture. So this implementation points are very good. That's why IoTWF has taken a reference from this particular reference model, because if you think about it, they have included each and every point which we could think of. Okay, then they are talking about interoperability and heterogeneity in a one kind of a detail. Okay, that heterogeneity of technologies in the IoT is significantly higher than in traditional computing systems. Okay, they include RFID, sensor networks, embedded system, mobile technologies. Like it is in your, if you say that I am only using RFID sensors, okay, that means that you are only using one kind of a hardware. Or let's say you have created a wireless sensor nodes. Okay, you have created two wireless sensor nodes, that means you have created a wireless sensor network. Okay, or you are doing something in the embedded system, or you are doing something in the mobile technologies. Okay, but in the IoT you have to make a use of each and every technology. Okay, you have to use the RFID, you have to use a different kind of sensors, you have to use the embedded systems, that means you have to use the microprocessor and microcontroller, and you have to use the mobile technologies, that means you need to use the applications which are being present in the mobile. Okay, so our IoT should be the heterogeneity of technologies. Okay, so several different kind of technologies should be introduced in our reference model, so that the developer or the architect can get the idea that okay, for doing this I have to use this. Like for processing my data, I need to either use a microprocessor or I need to use the microcontroller. For the microcontroller part, there are so many options available, something like that. Okay, then as we are integrating several different kinds of technologies, that means the interoperability of has to be supported in all the functionality groups. Okay, and the communication layers. Now, even for the communication technologies, it shouldn't have only a network present in that is in the internet. Okay, it also should have the gateway. That means it should be the combination of internet plus gateway, so that for the mission critical applications you can use the gateway, and if not, then you can use the internet. Okay, so based on that, they have created one kind of architecture diagram, that this is my IoT reference models. Okay, then based on my guides, they have created IoT reference architectures. Now, based on their case studies, they have created a domain specific architectures. Okay, but to create a domain specific architecture, they have to take into account the application specific requirements, like what are the requirements they need to achieve, and what are the stakeholders present, what are the existing architectures which are present through which I can take the reference, then some business scenarios as well. Okay, based on that, you will design a domain specific architecture. Now, this particular business scenario is also applicable to your IoT reference model. But you can say that this is the way which you can understand this particular diagram. Like this is the way they have created its own implementation. That there should be one IoT reference model. In one IoT reference model, reference architecture should be present. Then in IoT, in several different kinds of architectures are present. But there should be some unified requirements. Okay, which is being followed by every multiple architecture. And this unified requirements I can get based on my application specific requirements. Application specific requirements I can get from my business scenarios, different kinds of stakeholders, different kinds of architectures which are already present. Okay, so these are the reference diagram which you can use as IoT-A architecture. Now based on that, they have created one reference model which is a, you can say that a higher level reference model in the extraction. Okay, so that every kind of technical and non-technical person can understand. The IoT reference model is something like, one, there will be a domain model. Okay, for the domain model, there will be one information model which will contribute what kind of requirements are there. Okay, and what kind of knowledge you should have to achieve this requirement. And there will be one communication model. Okay, because we should know how they are going to behave. Okay, so the behavioral viewpoint, we need to understand the communication model. Now both this will combine and become the domain model, which is a top level. Okay, so this is the IoT reference models which IoT-A reference model has given. Based on that, what do we mean by a domain model? Okay, then in the domain model, which kind of things are present? Then users will be present, augmented entities will be present. Augmented entities means physical entity. Physical entity means your physical hardware. Okay, and the virtual entity means, if you talk about gateway, okay, then gateway is not some kind of hardware which you can see. Okay, or if you talk about internet, you cannot see the internet, but you know internet is there. Okay, so that will be your virtual entity in your IoT system. Okay, then there will be some kind of services which should be provided, like interoperability or the integration. Okay, integration of embedded system, mobile technologies, that particular point. Interoperability means if you are not using the open protocol, then the protocol should be interoperable. In the same way, what kind of resources you are using for the computation. Okay, that means either you will be using your that means where the data processing is happening. Okay, so which kind of entity we are using for your data storage, then which kind of resources we are using for the data processing. Okay, and it should also contains your devices. That means whatever sensors, tags, actuators which you can think of. Okay, so this is the domain model. That domain model will have this kind of information. But the communication model is the one which is related to our OSI layer architecture. Okay, it will have our network information. It will have our physical data information. Okay, so it has been divided into data layer, end-to-end layer, ID layer, network layer, link layer, and physical layer. Okay, now this physical layer is very much similar to the physical layer of the OSI model. Okay, that means it is not changed. So whatever in that we were saying that physical bits are being transmitted. Okay, here we are saying that okay, from the device, from the physical device, that is my sensor, that data is being generated, and we have to give this data to the upper layers. Okay. Now, so different kinds of, obviously we will be using different kinds of sensors, so we will have different kinds of data format. Okay, so those kind of communication related problems will be managed by the upper layer. It won't be managed by the physical layer. The only function of the physical layer is just to give the data to the upper layer. Link layer. This is very much similar to your data link layer. Okay, but it is not the same, like just like physical layer of the OSI and physical layer of the IoT layer. No, it's not like that. The link layer is different. How it is different, we'll see. In order to address the heterogeneousness of the networking technologies represented in the IoT universe, the link layer requires a special attention. Okay, in fact, most networks implement similar but customized communication schemes and securing solutions. In order for IoT systems to achieve full interoperability as well as the support of the heterogeneous technology and comprehensive security framework, this layer must allow for diversity. Okay, but at the same time, it needs to provide upper layers with uniform interfaces. That means that the function of the link layer is you can say that it is much more than the OSI layers data link layer. Okay, यहाँ पर हम लोग सारे concerns छेड़ेंगे that heterogeneous technologies. That means I'm using mobile technologies, I'm using embedded, I'm using wireless sensor networks, I'm using RFID. Okay, then how the integration of technology should happen, that is also being managed by the link layer. Then It will also give you the interoperability of your protocols. Okay, that whatever protocols, whatever devices they are using, but they should be interoperable. So that's why we can connect those devices. Okay, and even for your security framework, this particular link layer comes into the picture. Now, all of this information should be present in the link layer, but the link layer should be able to provide the diversity according to the application as well. Okay, so that means for healthcare it should be something else. Then for your autonomous vehicles it should be something else. Okay, so this layer should allow some kind of diversity in this kind of points like interoperability, heterogeneous technology, security framework. But at the same time, whenever the link layer is communicating to its upper layer, some kind of uniform interface should also be present, so that all these different kinds of data, it can just send it to the upper layer and in the common interface. Okay, so that so the upper layer can understand what kind of data is being given by the link layer. Okay, so it should give us the diversity as well as it should give us the uniform interface. Network layer is very much similar to your network layer of the OSI. Okay, it is very much similar to it, but my network layer should support manageability, interoperability, scalability. Okay, it should addresses all this kind of issues. Now, what do we mean by a scalable network? Scalable network means that how many end devices are present. Okay, if only one end devices are present, then it won't be an issue. But if you can say that there are several end devices, like 15 to 20 end devices are present, that means your network should be scalable. If your network is not scalable, then what happens is it won't be able to provide the same data to the 20 devices at the same time. Okay, so that's why different kinds of protocols were introduced for specifically for the IoT, like MQTT protocol. Okay, this MQTT protocol, but this MQTT protocol was designed, but even this MQTT protocol has some kind of scalability issues. Still, it is having some kind of scalability issues. Okay, so right now the research is being done on that particular area as well. But these are the things which you need to know, that okay, different kinds of protocols were introduced for specifically for the IoT, but they were not scalable. Okay, or they were not interoperable. So we need to, if we are designing a network protocol, then it should be manageable, it should be scalable, it should be interoperable. Okay. Then your ID layer. ID layer means the virtual entity identifier. Okay, that is split from the locator is a center for the first convergence point in the communication stack. That is the ID layer. Leveraging on uniform interfaces provided by the link layers, the ID layers allows for a common resolution framework for the IoT. Also, security, authentication, and high-end services will exploit this layer for providing uniform addressing to the many different devices and technology in IoT networks. Okay, so that means that this is the one which you can say that it will provide the first convergence points, or it will provide the virtual identity. Okay, but what is the point of this virtual identity? Like why it is being known as ID layer is because this ID layer will have the data. Okay, and it will have its identifier that okay, oh, this is the one which has this particular data. Now it is not necessary that only same kind of devices will demand this data. Okay, it will have different devices, and different devices will be following the different technologies. Okay, so that means this layer should provide data to each and every devices of the technologies. Now, as it should be provide data to the different devices in different technologies, that means this layer should have a uniform platform. Okay, that means it should be uniform in giving the data to my different devices. Now, how it can do it? That means it will have some security also. It will have some authentication also. Okay, that means you can say that in the later chapters, whenever I'm discussing the MQTT protocol, I will tell you that MQTT protocols means it is a publish and service protocol. Okay, that means it is a pub sub model. What do we mean by pub sub model? Publish and subscribe. My client will subscribe this particular model. Okay, so those clients which have subscribed my model like temperature, each and every client should get the temperature data. Okay, for that they should have some kind of security also. They should have some kind of authentication also. So this thing is being managed by the ID layer in my if you are following the IoT architecture. Now end-to-end layer. End-to-end layer means everything which you can think of, like this layer takes care of the translation functionalities, proxies, gateway support of turning configuration parameters when the communication process different networking environments. Okay, so this thing acts like the top layer. Okay, the top layer means it will have the all the ideas that are like if you are using two different kinds of architectures. Okay, in the computer networks you have seen the function of the gateway. What is the function of the gateway? It converts the protocol of one kind of architecture model to the different kind of architecture model. Okay, that means it will also be it will also translate the functionality. It will also translate the gateways. Okay, so this is the thing, this is the top layer, which is being known as end-to-end layer. Okay, now by building on top of this ID and network layers, now what is this the function of the end-to-end layer? Okay, I know this these are the functions which are being done by the end-to-end layer, but when we decide end-to-end layer on top of our ID and network layer, it will provide the final building block for achieving a global M2M communication model. Okay, so even though my communication layer, that is my network layer and my ID layer, is doing some kind of interoperability work, but this is the top layer will provide the whole thing. Okay, that means that whatever devices you are using, whatever technologies you are using, it doesn't matter, we will be able to connect it. Okay, so in a truest sense we can say that they will be able to follow the M2M communication model. Okay, so these are the reference models which IoT-WF architecture has used. There are so many reference models are available, but these are the major reference models which everybody uses. So we have discussed. In the next class, we'll discuss the M2M architecture and the architecture in which IEEE has introduced the security part. Okay, yeah, you can give your attendance and then you can leave. And then we'll start the VLSI lecture. Thank you, guys.
Thank you, ma'am.